Okay, today's lesson is 5b, second topic in chapter 5, and we're talking about polynomials. And what are polynomials? Are numbers made up of smaller numbers. So to show this example, what I have here is a statement. You just won $5,456,231. Now when you hear that number, the only part that you are that you want to hear is the 5 million part. Okay, we don't really care about that we get $31 and change. Okay, we are more concerned the fact that it's in the millions and there's 5 of them. Clearly, 5 million is a lot different if you just got $1 million. But again, if it was $30 instead of $31, no one's going to cry over about that. So how could I rewrite this number as far as logically, how do we comprehend it? This is really 5 million, okay, abbreviate, plus 456,000 plus 231 and change. So this larger number is really made up of this component plus this component plus this component. Okay, you could literally show it all written out. Okay, and all I did was separate it into categories. What we have here is a leading coefficient, and we'll talk about what that term means, of 5. 5 million is a lot different than 1 million. So that number is a lot more important than the 456 or the 231. And also the degree, the important fact is that this is in the millions. So this has to do with degree, and this has to do with the leading coefficient. Okay, so kind of, if you're kind of trying to understand the vocabulary in this lesson, come back to this slide and say, okay, how does it relate to the 5 million number? Okay, basically it's 5 million and change. What trumps this is the fact that it's $5 million. So let's take a look at polynomials. Polynomials, again, are numbers made up of many smaller numbers. So I'm looking at this example. This entire thing is like the $5 million, okay? And it's made up of 3 components, okay? Each one of those components is a smaller number by itself. They'll call these terms. The degree of the term is the largest exponent. So this is like the millions of dollars. So this is called a cubic, meaning that it's x to the cube power. So over here we have degrees, and you kind of look at those. If there's no variable, we call that a constant. If it's to the first power, it's a linear, hence a line. Quadratic, just got done studying those. Those are x squareds. And an x cubed is a cubic function. And it goes on and on and on. Okay? We also have to name the number of terms. We have names here. A monomial for 1 term. Binomial if you have 2 terms. And a trinomial if you have 3. So since we have 1, 2, 3 terms here, this is a trinomial. Okay? So we would call that number a cubic trinomial with a leading coefficient of 5, and again, the degree is determined by the fact that it's x cubed. Even though it has an x squared in it, that is doesn't mean it's a quadratic. It's just part of the number. The one that trumps it is the x cubed. So just like the $5 million, yes, you have thousands of dollars in there, but it's a $5 million number with change. Okay? So look at the second example. This is a binomial, and since it's to the 5th power, that's the largest one, we call this a 5th degree binomial. Leading coefficient, -1. Okay? So that's how we want to look at those numbers. All right, so on top of basic vocabulary, we have to know basic operations. How do we add and subtract and multiply polynomials? So when I see this number, this is a number minus another number. Okay, so like 5 million minus 1 million. Obviously, you line up the different pieces. Millions go with millions, dollars go with dollars, and so forth. So just like this, we want to combine like terms. Okay, so I'm going to look at this. First, switch the signs. So that becomes positive. We have a negative 3x squared minus x, and that becomes a positive 4. So I'm going to look. Where do I have like terms? Well, those two go together because they're both x squared. So 2 plus 3 is 5x squared. Then we're going to look, okay, what do we have next? X's. Then I'm going to go in order. This is called standard form, when you start with the largest exponent and work your way downward. Plus 3 minus 1 is 2x. Okay? And then I'm going to look at just what numbers we have by themselves. We have a positive 4. So my final polynomial is 5x squared plus 2x plus 4. Over here, okay, binomial times a binomial. A lot of times we call this FOIL. You probably heard it before. I don't like to use that term. I call it distribution. double distribution because you have term by term, 2 terms here. So what I'm going to do is first multiply to 5x times the 8x minus 4. So that's going to be 40x squared minus 20x. Okay, very similar to last chapter. Now I'm going to look at the second term, and I'm going to multiply that by the same second 2 terms. But notice what I'm going to do here. 3 times 8x, that's the same thing as 24x. I'm going to make a new line and stack my like terms. Notice my x's are in the same column. And then we have 3 times negative 4 is negative 12. So now I can combine these very easily like terms. So I have 40x squared plus 4x minus 12. Notice it's a lot like FOIL where you have the 40 is the first, the 2 inner and outside are the negative 20 and positive 24, and then the last is negative 12. Okay? So again, we're going to have the same outcome. We're going to follow the same process over here. Notice I'm going to take the first term and multiply it by each one of those terms. So I'm going to have 6x cubed. Next term, 2x squared. Next term, negative 6x. I'm going to now look at the negative 7, and I'm going to multiply it by all 3 terms. So we have negative 21x squared. Notice I stack up the x squared. So I'm going to find where does it go? X squared right there. And we go negative 7x and then positive 21. Again, combine all like terms. So we have 6x cubed minus 19x squared minus 16x plus 21. Sounds pretty good there. The last thing, I'm multiplying really 3 factors together. That factor, this factor, and that factor. Again, I'm going to start by factoring or multiplying the first 2. I'm going to leave that 3x to the end. So right now, in fact, I'm going to put that in a different color so we don't lose sight of it. So the first thing to do is the items in red. And again, I'm going to do it just like the top problem. So I'm going to have 8x squared minus 4x. So that's the first term. And then I'm going to do the second term, 5. And I'm going to have positive 10x minus 5. And notice I can combine those right away and now have 8x squared, combine my middle terms, and we have that element right there. Okay. Now, we can't forget about the 3x. So I'm just going to go and copy that down at the end, and now multiply, distribute that from the back. So first term, second term, third term. So we have 24x cubed plus 18x squared minus 15x. And again, that is our final polynomial for that expression. Okay. So here we have 4 examples, adding, subtracting, multiplying 2 binomials, a binomial times a trinomial, and number 4 is a binomial times a monomial. Okay. So those are 4 different types of problems we need to be familiar with. Okay, here's some special cases. What we have here is, what if the terms are the same, but the only thing difference is one's positive, one's negative? Well, you take the first term and you square it, and then you take the last term and you square it, and you simply say positive times a negative is a negative. So let's go ahead and look at this example over here. We see that they're the same, so I'm going to say 4x squared. And then we're going to look at the 9 and see that they're the same, so I'm going to square that as well. Then the only thing that we change is a positive times a negative becomes a negative. So 4x squared minus 81 would be your final answer. The same thing happens here. A plus b quantity squared or a minus b quantity squared. What's different is that middle term. This is a lot like completing the square. So let me go ahead and do this one by hand. So we have 3x. So this really means 3x minus 2 times 3x minus 2. And what we have is 3x minus 6x, and if I do the second term, I'm going to have negative 6x plus 4. Notice that middle term is repeated twice, so now when I bring it down, we have 3x squared. Oh, I forgot the square term there. Don't forget that. And minus 12x plus 4. Now, instead of going through this longhand every single time, we can look at this and say, hey, let's go ahead and square the first term, square the last term, multiply the 3 and the 2 together, and then double it, and then you get that middle term. So again, it's just a shortcut. If you don't pick up on a shortcut, that's fine. You can go through it by hand, and you'll get the same result. Okay, our last example here is a binomial cubed. So this really means x plus 2 times x plus 2 times x plus 2. So what I'm going to do is focus on the first two terms. Okay? So I'm going to have x times x is x squared plus a 2x plus another 2x plus a 4. So we have x squared plus 4x plus 4. Now I'm going to go ahead and multiply that by x plus 2. Now again, don't forget, this is one big polynomial. So I'm going to use parentheses there to show that. So now when I multiply this, I'm going to do term by term. And we have x cubed plus 4x squared plus 4x. Now I'm going to look at the second term, 2, and multiply it by the 3 terms here as well. So all I'm doing is multiplying from the back. No big difference. So 2x squared, I'm going to the x squared column, plus 8x plus 8. And again, everything is combined, and we can simply have a final answer. Write down your terms. 4 and 2 makes 6x squared plus 12x plus 8. So that is that expression multiplied out to that polynomial. So then this is 4 terms. Okay, it is third degree cubic, leading coefficient of 1. What I want you to work on for class tomorrow are these 3 examples. Again, a subtraction problem, a cubing problem, and a simple distribution of 3 times problem. Okay, so let's look on that for tomorrow, and we'll pick up from there.